Hello class, today we're looking at force problems that deal with law of sines and law of cosines. So yes, this is a physics topic, but we can use law of sines and law of cosines to solve force problems. All right, so a little bit of prior knowledge. Today we're going to be drawing parallelograms. So in a parallelogram, remember opposite sides are equal and they are parallel. Opposite angles are equal, and the biggie, consecutive angles, are supplementary. Okay, so what does this mean for us in force problems? Well, here we have an object. And we're going to have two forces acting on it. So one force is going to be acting in this direction. I'll call this force 1. And we'll have another object acting in this direction. I'll call that force 2. Okay, so then what happens is, because these objects are not acting in a straight line, but there's some angle over here that creates what's called, so some angle is applied. So this angle over here, it pushes these two forces, according to this angle, create what's called a resultant force that go in this direction. Okay, this is the resultant force right here. So what does that mean for parallelograms? Well, what actually happens is we actually create what's called we create a parallelogram. So if I envision this force 1 acting in this direction, I can extend this out this way. I'm going to draw a solid line. And this force is acting downward this way. So here's my force 1, here's my force 2. This resultant force is actually the diagonal of this parallelogram. So let me complete this parallelogram. And let me complete, close enough, the resultant force. Okay, so we actually created a parallelogram. Not a good parallelogram, but we'll see when we do the problem. So here, so let me give you the definition of what a resultant force is and how to find it. And then we'll draw this picture one more time. So a resultant force passes through the angle formed by the two forces. Okay? So if I have a force acting on this object in this direction, and I have a force in this direction, okay, we can create a parallelogram. So here's force 1, that's your force 1 pushing down, force 2 pushing across, creates at this angle creates a resultant force. Okay. So when we do all of these problems 1, 2, and 3, we're going to be creating pictures that look like this. Okay, so let's start with question number 1. It says, find to the nearest tenth of a pound the magnitude of the resultant force if two forces of 3.5 and 5.0 pounds act with an angle of 43 degrees. So here's your object. We have a force in this direction, and we have a force in this direction. And they're acting on that force at an angle of 43 degrees. So this is 43. I'm going to put 43 degrees here. You'll never see me do that again. Okay? So what happens is this. Notice in my parallelogram I have obtuse angles and I have an acute angle. So this is 43 degrees. So when I draw my parallelogram, I'm going to make this angle up here my acute angle. So here's our object. So we have one force this way. This will be my 3.5. And this will be my 5-pound force pushing on this object. So let's complete the parallelogram. And then this is the resultant force. I'm going to call it lowercase r. That's your resultant force. Okay? This angle is 43 degrees. Remember, there's your vertical angles right there. Okay? Now, how do I find this resultant force? Well, remember, it's just a diagonal of a parallelogram. Okay? You have two sides. Remember, opposite sides are equal. We know opposite angles are equal. And then, don't forget, we know these two angles are your consecutive angles, and they are supplementary. So we know this angle. 180 minus 43, 137. So this angle is 137 degrees. Okay, now let's go back to our, remember, law of sines and law of cosines. We have side, angle, side, and we're finding this missing side. That's your classic law of cosines. Okay, so we're looking for the resultant force, which is across from this angle. So that your r squared is equal to, well, cosine of 137 is way over here. I just have to fill in my 3.5 and the 5. Okay, and then everything else just gets typed right in the calculator. Here we go. So, 5 squared, 25 plus 3.5 squared minus 2 times 5 times 3.5 cosine of 137 equals. So that gives us 62.847 dot dot dot. And then, remember, we got to take the square root. I'll take the square root. And we have 7.9. Okay. Because remember, it said to the nearest tenth of a pound. Okay. So, we drew our parallelogram. Here's the resultant force. Here is the angle formed by the two forces. And remember, the resultant force always goes through this angle. All right. Number 2. Two forces act on a body so that the resultant force of 55 pounds, the measure of the angles between the resultant forces are 27 degrees and 46 degrees. Find to the nearest pound the magnitude of the larger applied force. Now this problem's still going to draw our parallelogram. We still have to draw the referent. We still have to draw the resultant force. Now the information is being done a little bit differently. Okay. Now, again, remember when I did this problem here, I tried to make this angle the acute angle, and this was our obtuse angle. I'm just trying to be accurate with my problem. This resultant force right here, remember, splits this angle. They're not in half, but we know what the angles are. One's 27 degrees, the other's 46 degrees. So if I add those up, that's not more than 90 degrees. This is acute. So when I draw my parallelogram, I want to make this angle up here my acute angle. So here's force 1, here's force 2. I'm going to complete my parallelogram. And then here is my resultant force. Okay, so this is the resultant of 55 pounds. Okay, now, so the way I've drawn this picture, this is my, here's my smaller force, here's my larger force. Well, opposite sides are equal, so this is F2 and this is F1. So remember, the larger angle is going to be across from the larger force. So I'm going to put the 46 here, and then I'll put the 27 here. Okay. Our job is to find the larger force, which is, to the nearest pound, we're finding the magnitude of the larger force, which is this F2. Either this one or this one is the same thing. All right, so now how do we answer this question? Well, we know this whole angle. We just have to add it up. Okay, so 27 and 46. That is a 3, carry the 1. That's 73. Okay, and we know this angle right here. If this is 73, this is 107. Remember, 180 minus 73. 103. So now I know all the angles of this triangle. Remember, parallel lines, alternate interior angles. This is 27 here. This is 46 there. Okay. Well, I have all the angles one side, and I'm going to find this side right here, this side right here, which is this. Okay. So force 2 over the 46 degrees, so sine of 46 equals the 55 over sine of 107. Okay, well, it's just calculator work. I'll let you digest that. Okay. So I have 55 times the sine of 46 divided by sine of 107. Sine of 107. And we have force 2. The larger force is, what's it say, to the nearest pound. So 41. Larger force is across from the larger angle. Smaller force, smaller angle. Okay? It's your geometry stuff. All right, last question, 3. Two forces of 40 pounds and 28 pounds act on an object. The angle between the two forces is 65 pounds. Find the magnitude of the resultant force to the nearest pound. Okay, so classic, this is just like question number 1. Again, this angle is acute, so when I draw my parallelogram, I'm going to make this up here my acute angle. Okay. So here's the 28, here's the 40, and this whole angle is 65. We need to find the resultant force. Here's the resultant right there. All right, so this just like number 1. We have to find this angle. 180 minus 65, that gives us 115. Okay, so that's our, I'll put 40 down here. So here we have our side angle side. So that's your law of cosine setup. So r squared is equal to, and I'll just get it all written out for you. Minus 2 times 28 times 40 cosine of 115. All right, now it's just calculator work. And to the nearest pound is our final answer. Okay. So 28 squared plus minus 2 times 28 times 40 cosine of 115. And we have that big number. And I just take the square root. So to the nearest pound, 57. So the resultant force is 58 pounds. All right. Now, last question, the last part. It says, using this answer, find to the nearest angle formed. Using this answer, find the measure of the angle formed between the resultant, so the resultant, and the smaller force. Well, 48 and 20, which one's smaller? 28's the smaller force. So we are finding this angle right here, this portion of the angle. Remember, the whole thing is 65. We're finding this portion right here. I don't need to find this part up here. I have all the information in this picture right here. This is your 58. We just found it. You have we're finding this angle. We have all three sides. We have this one angle, and we can find this angle. Actually, you can do this in two different ways. You could use the law of cosines to find this angle, or else you can use the law of sines. I'm actually going to use the law of sines to find this one. I think it's just an easier setup. Okay, so here's my 58 over sine of 115 degrees, and that is equal to the 40 over the sine of, we'll pick a letter, I'll call it A, okay? And now remember, everything now is done right in the calculator. Remember what we did before to find angles. In this case here, eventually we're going to have to do inverse sine, okay? So we're going to multiply these two, divide by the 58, and then we're going to do inverse sine. Okay, so in your calculator, whatever this answer is, I would do all this calculations first and then do inverse sine of your answer. But you're multiplying these two, and you're going to divide by the 58. And it says to the nearest degree, so once we get that all typed in, we'll be done. So I'm going to get that in first. So I have 40 sine of 115 divided by 58, hit equal. Now I'm just going to do second sine, second answer. And so we have 37 degrees. So that angle is 37 degrees. Okay? I'm not going to do it, but I will do the setup. We could have used the law of cosines for this, because you have all three sides, and we're finding that angle. So that means 40 would be on the outside. So 40 squared would equal 2. Then we would be doing 28 squared plus 58 squared minus 2 times 28 times 58 cosine of x. Let me slide that over for you. Okay, cosine of x. And then you'd have to do your algebra like we did before, and you'd come up with 37 degrees when it's all said and done. Okay, that's our force problems.